Okay, Algebra 2 fans, this is our assignment, worksheet 3-5, Totally Radical. It's a review of all the types of radicals that we've done with simplifying, evaluating, multiplying, dividing, and adding, subtracting, all of this stuff. It's a nice review. I'm going to work through this. Now, I'm going to do this quickly, so my suggestion is for you to try to do this yourself, and then if you need to, pause it in places, because again, I'm going to go through this fairly quick. So if I'm going too fast, pause it, look at what I've done previously, and then come to the next part. So the first one is evaluate. Evaluate usually means come up with a numerical answer. So we're not going to be dealing with variables, we're going to be getting actual answers. The square root of 144 is 12, and we're going to multiply it by the cube root of 343, which happens to be 7. 12 times 7 is 84. That's it. Part B, the fourth root of 625, we simplify that as 5. And the fifth root of negative 100,000 is actually negative 10. 5 plus negative 10 is negative 5. Part C, the cube root of negative 27, which is negative 3, divided by the square root of 36, which is 6, reduces to negative 1/2, or negative 0.5. Number 2, simplify the following expressions. Okay, when we do this, there's several ways to look at it. The first way is to do a factor tree for this number 405. So for example, that would be 5 and 81. 5 is prime, I circle. 81 is 9 times 9. 9 is 3 times 3. And 9 is 3 times 3. So then I rewrite the square root. It's the square root of 3 times 3 times 3 times 3 times 5. And then the variables, we have x to the 4th and y to the 5th. Everything is multiplied here. Now, if you are simplifying a square root, you're looking for perfect squares to pull out. A perfect square is a pair of numbers or variables that repeats, and so we're going to simplify that. For example, 3 times 3 is 9. That's a perfect square. The square root of 9 is 3. So when I pull out a pair, I write it down once. Here's another pair of 3's, so I'm going to write that again. Now, when I pull out two pairs of x's, that's going to be x and x on the outside. And then for the y's, I have two pairs of y's, so it's y times y. You can see this is kind of messy. And then whatever I have on the outside gets multiplied. So 3 times 3 is 9. X times x is x squared. Y times y is y squared. Now whatever I didn't pull out stays underneath the radical. So we still have a 5, we still have a y. So the answer is 9x squared y squared, square root 5y. Part B, same thing. Now it's a cube root, so what I'm looking for actually are triples. I'm looking for a group of 3 numbers that are the same. Now here's the thing. So I can do 125 times 2. But if I recognize, you know what, 125 is a perfect cube. It's 5 times 5 times 5. Now I can keep breaking this down, but if I recognize, you know what, that's a good number, I'm just going to keep it like it is. So I'm going to keep that as 125 times 2 times k to the third, because the cube root of 125 is 5. So I'm going to pull out 5. Now k to the third, there's 3 of them. That's a trio, or that's a triple. So a cube root of k to the third is just k. So what happens now, again, the outside, I multiply that, that's 20k times cube root 2. That's my answer. Part C. A square root times a square root, we're allowed to write that as one big square root, where we multiply the 12 and the 6, and we multiply b to the third times b to the fourth, which is the square root of 72, b to the 7th. All right, now, again, we're looking for numbers that are perfect squares. So you might say, you know what, 9 times 8, that would be good. But actually, there's a bigger number than 9. You can think of 72 as 36 times 2. The square root of 36 is 6. So right here, I'm going to stop. Now I could keep breaking it down like I did in part A, and I would eventually get the answer. But this is going to be faster I can just pull out that square root of 36. So I'm going to take a 6 out. b to the 7th, I'm trying to take the square root of that. So I'm thinking of, okay, pairs. 3 pairs of b's, and then there'd be 1 left over. Think of that as b to the 6th times b to the 1st. So that's 3 pairs of b's, b to the 3rd, and then what's left is square root 2b. That is a simplified answer. And you can check this. You can always check it on the calculator. If I take my original problem, and I'm going to write this, instead of using b, I'm going to use x. 12x to the 3rd, close parentheses, times square root 6x to the 4th. Now, my question is, oh, actually, you know what? I should have done something. I'm going to pick a value for x to store, just a random number. I'm going to take the number 5. Okay, so hold off on that. I'm going to do 5, store for x. Now I'm going to type my expression. So it gives me 2,371.708245. If I take my final answer, it should give me the same value. Because when I simplify, I don't change the value, I just change the way it looks. So is 6x to the 3rd square root 2x, is that going to be the same value as the original problem? Yes, it is. So what that tells me is that this answer is correct. I did it right because I have not changed the value. Okay, now for number 3, we're going to add, or in this case, subtract radicals. If you subtract, you can only do this if they have the same number underneath the radical symbol. And they both have to be square roots or cube roots or fourth roots. That's negative 9 root 7 minus 1 root 7. So I do negative 9 minus 1. I get negative 10 square root 7. That's a good answer. Now for number 4, these are different radicals, different numbers, so I cannot combine these yet. But let me simplify. 18 is 9 times 2. 9's a perfect square, so when I take that square root, it's 3. So what I get is 3 times negative 6, negative 18, and what's left underneath is 2. 8 is 4 times 2. 4 is a perfect square, so I'm going to pull that out. That's a 2 out there. So that becomes 2 times negative 7, minus 14. Square root, 2 is left over. Now the minus 3 root 6, I can break down 6 into 2 times 3, but neither of those is the same. So it's not a perfect square. I just leave it as 6. I don't need to break that one down. Now let's see, we've got negative 18 square root 2, negative 14 square root 2. We can combine those. What you do is you subtract or you add the coefficients. The radical stays the same. That doesn't change. So that's negative 32 square root 2 minus 3 square root 6. And that's it. That's as far as I can take it. I cannot combine this. A square root 2 and a square root 6 are different. Number 5. Now we're dealing with cube roots. Okay, so we're thinking of perfect cubes now. 24. All right, so let's say you go 4 and 6, 2 and 2, 2 and 3. So that's 5 cube root 2 times 2 times 2 times 3. We're looking for groups of 3. There's a group of 3. Let's pull it out. That's really 8. Cube root of 8 is 2. So 2 times 5 is 10. Cube root 3. And then over here, now I know that 81 is actually 27 times 3. 27 is a perfect cube. The cube root of 27 is a 3. So I'm going to pull that out, and what I get is 3 cube root 3. That's a plus symbol between them because it's positive. Now the last one, minus 2 cube root of 3. That's already simplified, so I just copy that. So we got 10 plus 3 minus 2. So we get 11 cube root 3. And that's your solution. Now, number 6, we're going to multiply. When you multiply, this is like a binomial times a binomial, so we're going to double distribute here, or what you call FOIL. I'm going to do 9 times 1 plus square root 11. So the 9 multiplies this parentheses. And then the square root 11 here multiplies the same parentheses. So plus square root 11 times 1 plus root 11. Okay, so what happens here, I distribute. I'm going to get 9 plus 9 square root 11. Plus, over here, this becomes square root 11 times 1 is square root 11. Square root of 11 times itself is just 11. That would be the square root of 121. And the square root of 121 is just 11, so I'm going to substitute that. Now let's see, can we combine anything? Well, you've got 9 plus 11. Those are just constants. Combine those, we get 20. For the radicals, we have 9 root 11 plus 1 root 11. So that's plus 10 square root 11. And that's as far as we can take it. Now let's see, did I do it right? Well, take the original problem, 9 plus square root 11. Notice that I did a double closing of parentheses. The first one closes the square root of 11. The second one closes the whole thing, which I need. Times parentheses 1 plus square root 11. Double close. Now I'm going to get some decimal, 53.16, 17 I mean. My answer is 20 plus 10 square root 11. Is it the same? Bam. Look at that right there. Beautiful. Same thing. Okay, so there's number 6. Number 7, we're going to do this again, this process. So the 3 is going to multiply this parentheses 3 plus 2 square root 5. And then minus 2 square root 5 is also going to multiply. We call this double distributing. You're taking both terms in the first parentheses and you're multiplying them by everything in the second parentheses. So what we get, that's going to be 9 plus 6 square root 5. Now over here, this is going to be, multiply that, that's minus 6 square root 5. And then minus 2 root 5 times 2 root 5 is minus 4 square root 25. Okay, I'll write it like this, but what you want to realize is that the square root of 25, hey, that's just 5. Root 5 times root 5 is just 5. Now what happens here, you have positive 6 root 5 minus 6 root 5. That's 0. So we get 9. This is going to be minus 4 times 5, which is minus 20. And we get negative 11. Wow, that's it right there. Now this is one, I'm going to check this. So 3 minus 2 square root 5, remember close parentheses twice, times 3 plus 2 square root 5. Wow, negative 11. Okay, it worked. Now what we'll do is we'll stop here, go to part 2 of this, and we'll do 8, 9, and 10.